Looks like some people are showing up. If you can hear me and everything's fine, if you could just say something in the chat, then I can know everything's fine. Thank you guys for being ready. I know I'm a little bit behind today, but this is recorded, so you will get to, you can check it out later if you need to. Okay, looks like some people can hear me. I had a really good summer. I did a lot of landscaping and house renovations and stuff. So, I mean, other than, you know, all the crazy stuff going on. Okay. Where to start? So I think I'm just gonna, well, I'll tell you guys, but I'm probably gonna have to mention this a few times as people show up. But because I'm not sure if it just starts them where I'm at. I think it does that, or if it starts them at the beginning. Let's see, how many people? 4. And how many people do we have in the class? I think there's a way I can make this. Right now it's set to a little bit of a delay. Oh, wait. Forgot to change the name. Well, we have 4 people. I guess we can get started. Anyone that's not here, they can, oh, now we have 5. They can catch up. They can watch the video later. It's no problem. I'm not doing attendance. For this, just gotta make sure you're hitting those due dates. Do I have due dates on this course yet? Does not. Well, it's gonna load. Yes. Okay. So we had 2 assignments that were due. One extremely simple question that we might talk about a little bit. Okay. There's 3 organizations that we would use a database. So I haven't looked at what you guys put yet, but anything, basically any organization could potentially use a database. Any business definitely. Um, if you were like a one-person small business, you could probably just use an Excel spreadsheet. But anything more than that, where you have more than a handful of customers, or you're getting new customers all the time, you're going to want a database for that. So businesses, hospitals, schools, what kind of things? Why don't you guys list some of the ones that you had? Oh, thank you, Brendan. Why don't you guys, if you had something other than a business, hospital, if you had something specific, put it. I don't think there's a wrong answer here, but we might come up with something interesting. This is just to kind of make you think for a second, and it's not that much of an investment. But then this next one here. So in the previous semesters, before we look at this, I guess did I put this in here? Basically, how you're supposed to do this course is you start at the top module and you just kind of work your way down. Nope, it's just stolen right from the syllabus. Okay, anyway, I guess I didn't say that anywhere. I need to make like a video of how to do the class. Anyway, I'm just going to do this for now. So each module has different items in here. For example, this first one's basically for the syllabus, and then some videos here. So the first one is kind of a TED Talk. You can check that out. It's pretty interesting, actually. Then here you're going to get a blast of the terminology and stuff. All the answers to this assignment, exploration assignment, should be in this video, or most of them are. Anyway, watching that video makes this a lot easier. Okay, and then I think I need to turn this off. That's not what I clicked. Yeah, okay. We don't need that anymore. So the few assignments I've given you so far are not really anything technical or hands-on. So the next one that's due, we should probably talk about that. So we got till September 7th for ER diagrams, homework 1. So let's talk about ER diagrams. And so I put some PowerPoints on here, didn't I? Yeah. Anyway, so you're meant to go down through these. So this is, I think these are videos. I found all these, but yeah, okay. So if you haven't already, make sure you're going through this material, because that's where I'm pulling everything from. I'm assuming you've, for today it's fine, but I'm assuming you're going through and watching these videos and answering the questions, because that gets you set up for the more technical part. Okay, so here, intro demo. This should be the file. So here I made a PowerPoint that goes step by step through the process of creating an ER diagram. And so you may want to know, what the heck is an ER diagram? Okay, so it stands for Entity Relationship Diagram. And basically, what we're going to be learning in this class is how to design a database properly and how to actually implement it. I've done a website in the past. We might do that again, maybe. But Replit now has an SQL part to it, so we might actually use that and just cut out the other part, because it always confuses people if they haven't taken 099. Okay, anyway, ER diagrams. So an ER diagram is a blueprint for designing a database. The first part of this course, we're going through what are the steps to design an ER diagram, because once you have an ER diagram, you have a map that allows you to code the database and have it all organized. Some people skip the planning step. If you know, a lot of people that use like Excel spreadsheets to keep track of their business, or even to some degree Access. Most people that are using Access or Excel, they're either doing something on a smaller scale, or in the case of Access, they're usually using it wrong. So we're going to start from the ground up. What are the basic building blocks? What are the basic rules of what makes a good database? Why does it matter? Some of those earlier videos talk about why it matters and how powerful it can be. And if you understand it, you can utilize that, get a good job and whatever. Anyway, so the design steps for designing a database. So we'll start here, and then we'll go through the steps, and then we'll look at the actions that you can take. So the first step here, we're not going to look at the first step first. We're going to actually skip to the step 2 first, because it actually makes step 1 make more sense. Okay. Okay. So I don't know why I put 2 in red. I guess that's the most important. So we will do a demo of 2, but we won't do a demo of 1 till later. But what is requirements analysis? It is basically you are deciding the best way to organize the data for an organization that will make their lives the easiest. Okay, so this involves things like consulting, shadowing employees, and this could take like a year or more depending on the size of the organization. And so the person that gathers the requirements would be like a consultant, and these people make like $80 an hour. And then so they put you in this organization, and you work there for a year just following people, watching what they do, how they use the data, and basically looking at all the paperwork. What things do they use on the paperwork? What things do they not use? And they compile all that information, and you distill it down into an ER diagram, basically. So in the beginning here, I'm not going to require that you do that. We don't have time for you to go work at a company for a year and gather information. So I just give you that. I give you the analysis. I give you the requirements. And a lot of times they're very vague. So in those cases, you can just make assumptions. Okay? If it's a bike shop, maybe it sells motorcycles, maybe it sells bicycles, maybe it sells both. Maybe it's a restaurant. I don't know. You can make it whatever you want. As long as you do include the things that I want you to include, the rest you can make assumptions. Okay, on the requirements. Oh, and I said that here, I guess. This always bothers people in my classes because there's not always one right answer. Okay, usually there's answers that are better than others, but there's not necessarily just one right answer. So if you can argue that your answer is right based on the wording, then I'll take that. Okay. So data modeling, step 2. This is the part where you actually learn the process. Okay. So you work on making the ER diagram, entity relationship, and it's a good name because there are 2 parts to an entity relationship diagram. Okay. Okay, I forgot to check you guys out. Okay, Microsoft. Oh, definitely Microsoft. Okay, Amazon definitely for sure. Good. Those are really good suggestions. Okay. Anyway, So an entity relationship diagram has only two parts, entities and relationships. Okay, so we only have to learn those two things, and we can build these diagrams. Okay? If you don't know what the word entity means, make sure you look that up. All right? Everyone knows what relationship means. Okay. And then these other steps will make more sense later. Once we model out our entities and how they're related, we'll assign fields, which are the attributes. So, for example, if we had a customer entity, okay, it may have a name, a first name field, a last name field, phone number, address. Okay, so those are different properties of that entity, but we store those in fields. Okay, and we'll talk more about primary and foreign keys later, but I will say primary and foreign keys are special types of fields that have to do with, well, primary keys have to do with data integrity, okay, and that'll make more sense when we look at it. Foreign keys are for relationships, okay, so with primary keys we have a field that allows us to uniquely identify a record, or an entity, basically an instance of an entity. Foreign keys are attributes that tell us how things are related. For example, let's see, maybe like a zip code, right? If you have a zip code in your address, you know, that zip code is tied to a city, right? Cities have zip codes. Your driver's license number, maybe, tells them, you know, who you are, but there's no one else has your same driver's license number. Okay. Moving on. So we'll be focusing on the data modeling step in the beginning. I'll mention this next step, but it's kind of out of the scope of this class. Okay. When I was getting my degree, I swear I took like 8 different classes on database. So what I've done for this course is to kind of distill down what is the most important basics that you need that should get you going on your feet in a database situation. Okay, anyway, this is one of those things that is kind of extra, and it's very important, but for our examples, we're kind of going to gloss over it. I've got some tricks that allow you to kind of skip these complicated logic steps. But you'll see something referred to as normalization. And what this does is it's a set of steps that you follow to minimize the amount of data in your database by reducing something called redundancy. And redundancy is basically having extra, or having like if you have extra copies of something you don't need, like why would you ever need 2 copies of the same file in a computer if they're the same? You don't need that, right? Because you could just infinitely copy the first one if people need to download it or something. Okay, so what this is it's a very formulaic process where you take a look at each field and how they're related, and you reorganize your entities to follow a bunch of logic rules. Anyway, I have a simple step that we'll follow. One thing that's important to mention about this is designing something should be an iterative process, especially with ER diagrams. So a lot of people don't like this, especially in classes, which is unfortunate if you're in this class or any programming classes, having to do things over. All right. So writing a program or designing a program or designing a database should be an iterative process, which means you're going to have to redo certain parts. Okay. So with a database, when you're deciding on your entities and your relationships, you may find later that you thought of a more efficient way, so you have to go back and redo that. Some information may come to light about the business that's something you may have forgotten, or maybe they just expanded or added something. Anyway, things are always changing. So you need to have a plan. And once you guys see some examples, it's pretty straightforward. Anyway, maybe we should just take a look at it. Okay, so here's the example. So the rest of this PowerPoint is going through the actual steps of building the ER diagram. Okay, so here's our requirement analysis. Okay, so I told you these were going to be vague. All right. So it says, a hospital wants a database to track doctors, patients, appointments, rooms, and prescriptions. Okay, so I'm going to make an entity relationship diagram. I've linked in here a website that will allow you to draw diagrams easily. It's web-based, so you don't have to download anything. And let's see, is anyone panicking? Nope, okay. You can check that out. So the pictures I used in here, I believe I used that to draw. You guys will be creating your own ER diagrams, so maybe I think I have a demo video of that, or I posted one from YouTube or something. You can check that out. It's a very useful tool for creating your diagrams, and it's free, and it's web-based, so you don't have to download it. Okay, so this first step of creating this plan or creating this diagram is just creating a list of the entities. Okay, so what is an entity? It says it's any definable thing, a person, object, concept, event that you can store potentially multiple pieces of data about. Okay, they're usually nouns. So we could have a customer entity, we could have a student entity. If we had a student entity, for example, we could have Reed as a student, we could have Riley as a student, we could have Brendan as a student, and they would all have different student ID numbers, different addresses, I'm assuming, and so if there's information you want to store about something, that something is probably going to be an entity. Okay, so in our example back here, we want a database to track doctors, patients, appointments, rooms, and prescriptions. So those are going to be our entities for this example. All right, so down here, I go ahead and listed those. Doctors, patients, appointments, rooms, and prescriptions. Back here where I introduce entities, I put it in a rectangle here. In an ER diagram, you represent your entities with a rectangle. So here I've got my 5 entities: doctors, appointments, patients, rooms, and prescriptions. Okay, when I did this originally, I did it on paper. When I learned it, it's so much easier on a computer because you can move things around. So I highly recommend using that tool. I guess you kind of have to, unless you're going to mail it to me. I don't recommend that. If you're taking this online class, you can just email or just submit it, I guess, here. As you learn to use the digital tool. If you need help, I can totally help you. Okay, so we added our entities. That's half of the entity relationship diagram. Next part, relationships. All right, this is the part where you really need to pay attention to understand how this works. Okay, remember, we want our database to be efficient. Okay, we don't want to store copies of extra data. We want to be able to access things quickly. All right, and so how we design it affects all of those things. Okay, and so a big one is relationships between entities. Okay, so you take 2 entities. You can use process of elimination, but for most of these, they're common sense. For most of the examples I'm going to give you guys, they're going to be common sense. But there are some complicated ones when you make databases about, random machine parts and things. You don't always understand what's going on. But it doesn't change the process. Okay, this will fit to any organization or business. Do you need something? Okay. So anyway, you could use process of elimination by saying, okay, you take one entity, and you take another one. So let's say doctors and appointments. Are doctors related to appointments? So let's think, in the doctors entity, let's think of an example of an entity. So let's say we had Dr. Bob, okay? And then for appointments, what do you think happens when you make an appointment? Right? They record what? The patient's name, the date and the time, and what? Who they're going to see, right? So you can't really have a doctor's appointment without a doctor, right? So doctors and appointments are definitely going to be related. Okay. All right. Oh, that's not the one I did. Anyway, so that's a preview. Doctors appointments will be related, but how are they related? Okay. So we had entities as rectangles. Relationships are diamonds, like this down here. And they use lines. You draw lines between entities through relationships. They're usually verbs. The name of the relationship, don't get caught up on the name of the entity or the name of the relationship. You need to name it something so that you understand what it represents. Okay? Because this is your blueprint, this is your map. The reason you're creating it is so that the database you design makes sense and it works. It's watertight. Another reason you create that blueprint is someone else may take your job in the future, and if they have to manage that database, if they have that blueprint, it'll make their life a lot easier. And so if you ever get a job in the future and you're in charge of a database that's been around for a while, you're going to notice a lot of the rules that we're going to go over in this class are probably being broken, and you're probably going to want to fix it, but depending on the size of it and whether it's being used, you can't really, it's dangerous. Okay, anyway, it's time consuming. So once we have our entities, we're going to add in our relationships. So use logic. So basically what I'm saying here is use your common sense. You can guess. Again, this I mentioned earlier, this is a situation where there's more than one right answer, but usually there is a righter answer. So just get something that works, and then when we discuss, we can talk about why one might be better than the other. All right. Okay. So here in this example, it says, how are doctor and patient related logically? Okay, so you can just say it out loud. You say you read one side, noun, verb, noun, and then you go back the other way. So here, a patient comes to see a doctor, and a doctor sees patients. It's going to be important to say to think about this for the next part, because we have to decide there are actually different types of relationships between entities. Okay, and I feel like I need to reiterate what a relationship is. All it is data that represents a relationship between two entities. Okay, so you have to think about it more vaguely. It's not saying how is Dr. Bob related to Jim the patient. It's talking about how are all doctors potentially related to all patients. Is it just each doctor can only have one patient, or is it a patient can only have one doctor, or can the patient have multiple doctors? These are all things that you would learn through the requirements analysis. If you got to the point where you're making the diagram here and you didn't know the answer to that question, you would stop and go figure it out, okay? So I went through and I added relationships to a few of the entities here. So doctors, or you could read it either way, but here it says prescriptions are prescribed by doctors. Okay, and you can think a little bit of the physical artifacts involved in this. So the paperwork, okay? A prescription potentially could be written down on a piece of paper, right? That's going to have the doctor's name, the name of the drug, the date, all of that information, okay, needs to be stored. We're not going to store the information about the doctor in the prescriptions, but we need to represent that with a relationship. All right. And then prescriptions are also prescribed specifically to patients. We already talked about patients and doctors. So here are some example relationships between different entities. Okay, so we're building out our diagram. And I will just say, the diagrams that we work with in this class start out pretty small. They do get bigger, but they're not even close to what like a real organization might need, with all of its different departments. You know, they might need a database that ties in accounting, manufacturing, the warehouse, shipping, employees, payroll, human resources. All of these things may be tied together in one database. So you can imagine how many different entities there would need to be. Okay, so we put in some relationships, but we need to decide what type of relationships to use for each relationship. Okay, so our options are one-to-one. I'll just tell you now, those are for very specific situations. I don't think there are any. I don't think I asked you to use any, but if I did, it'll be a surprise to me. Okay, the next two are going to be the most common, one-to-many and many-to-many, okay? And it is important to do this step because it determines how your tables are going to look in your database, so how the data is going to be organized. If you choose the wrong one, it just won't make any sense. So usually the right one stands out. Okay, so I will talk about these, but you can always look back later, rewatch the video, or look at the slides, and make sure I'm still filming here. Okay. And nobody is panicking. Okay. So, one-to-one relationship, not a very common relationship. Let me describe this illustration down here. So, this is supposed to represent two different tables, okay? And if you are observant, you may notice something about these tables. We have the patient's table, and we have patient contact info. Okay, so these are two separate tables. If I added a new patient, I would have to add a record in the patient's table and then add in their contact info here. Okay. And so I tried to break it down. If I want to have a table that keeps track of patients and a table to keep track of patient info, that means each record in the first table would only ever match with one in the second table. Now, bonus points, fake bonus points, if looking at this slide, you can tell me, how do I know that Jim Smith's phone number here is 555-5551? How do I know that? These are two different tables. What is telling me in either of these tables that this is Jim Smith's information? I'm getting a little off topic here, but I'm just curious. Okay. I know the stream is off by a little bit, so I'm going to give you a little bit of time to think about it for a few seconds. You can pause if you want to try to figure it out, but then I'll just tell you. Okay, so you may notice that these tables both have 3 fields, okay? The patient's table has patient ID, first name, and last name. These are the fields. So each row, each horizontal row represents one instance of a patient. So Jim Smith has a patient ID of 1. So anything with patient ID 1 can only ever be Jim Smith. This field here would be the primary key, because we would never give another patient ID 1. That wouldn't make any sense. We wouldn't be able to keep track of them. So what over here tells me that this is the information for him. It's this field right here. So we have patient ID here and patient ID here. So this record ties into this one, and we know that because they have the same patient ID. Okay. Now, why would we do this? Because if you're paying attention, I could just put phone number and address in the patient's table and then just save myself. I don't have to have 2 tables. But what? So this is extremely, the reason here is extremely advanced. But I put it on here just because I know some people are curious about it. I will explain it. And then later on, if you are in a situation where you need to know, you can go back and look. Okay. It's not something I would ask you to know for a test. So we looked at how to create an ER diagram with entities as the rectangles, relationships as diamonds. We draw a line. An entity should always connect to a relationship. Okay. And then here, I believe this is called Chen's notation, and I posted a link to that on the module, so you can check that out. It's a very simplified and quick diagram style for ER diagrams. There's another one I posted a video to, so you can look at them both. It's good to be just familiar that there are different ones, so that way if you're in an interview or something, you can say, yeah, I learned this one, but I've seen the other one, so, they represent a lot of the same things, just differently. Anyway, here, the one-to-one relationship, you have the number 1 on both sides. Okay? So if I just looked at this would be a database with a table of patients, a table of contact info, and each record in patients would match up to only 1 record in contact info. Okay. So why'd I ever use this? Here's the wall of text you can read, but I'll give you the short version. It has to do with the way data is physically stored inside of the computer and the way a hard drive reads the physical disk, and it reads records out of a database. If it only needs to pull a few, basically the fewer fields and records it needs to pull, the faster it'll go. So in a one-to-one, we can separate out the contact info from the name and address. And so if we had a common reason to pull everyone's contact info a lot, it would be much faster if we could just pull that table instead of having to pull both tables or pull the larger table combined. This is something that helps only on like a humongous scale, but on a much larger scale, it can make a huge difference in performance. Okay, anyway, you guys don't even know what we're talking about yet, and I'm trying to tell you how to optimize your databases. Okay. A more common relationship is the one-to-many. Okay, so you can read the technical thing here. Let's just take a look at the picture. Okay. A one-to-many relationship. So we had the patient's entity and the appointments table. So let's think about it logically. This is what you do. You think of 2 entities, and then you say that, this is what I do. I say it out loud. I say it in my head, but I'll say it out loud so you know. A patient can have how many appointments? Okay? Logically, if I go to the go to the doctor and I want to make an appointment, how many appointments can I make? I could make one for next week, and then maybe I want to schedule something 6 months later. So most places I would assume a patient could have multiple appointments scheduled. Okay? How many patients should one appointment have, do you think? Have you ever gone to the doctor and, like some sort of shared taxi cab or shared Uber, you go into the doctor and he treats, 3 people at a time? No, that probably doesn't happen all that often. So each appointment should only ever have one patient tied to it. Okay, so I drew some lines here on the PowerPoint to kind of show you. In the first table, we have 3 patients, Jim, Sally, and Bob. In the appointments table, there are 3 appointments. Okay? How many appointments do you think Sally Jones has? How do I know how many appointments each person has? What tells me how these tables are related? What tells me in the appointments table who the appointment is for? There's a field here, and I'll tell you now, this is called a foreign key over here, and over here it's called a primary key. We'll go into more detail on that later. But one thing that's important to mention about the primary key is, notice we don't have any repeating numbers here. Okay, so patient ID in the patient's table is the primary key. Every value has to be unique. So we add another one. We can't add a 1, 2, or 3. It has to be 4 or higher or whatever. Over here, as a foreign key, we are able to put multiple copies of the same value. Why? Now remember what we're trying to represent by putting this patient ID here. What this is, I can tell you, why is each piece of information here in this table? So why is the appointment ID in here? That's so we can keep track of different appointments. Each appointment should have a different ID. All right. Location, where are they meeting? Okay, for the appointment. So, we could have different appointments in the same room, probably not at the same time. Here I didn't put time on here, but I'm trying to minimize the clutter. But here's the field, patient ID. What is the point of this field being in the appointments table? The only thing is just to tell you which patient is for that appointment. Now, there's 1.5 million things that I'm not going to say specifically, but you're probably going to notice, and you need to ask questions so I can fill in those empty blanks. But this is one that I think I always forget to mention, and you just have to figure out. But look at each field in these databases. There's only ever one value in a field, okay? You want to make sure you follow that pattern as you design your databases. One value per field, okay? There are ways to work around that, but they cause a lot of problems down the line. All right, so here, what these tables are telling us is that Jim Smith has 2 appointments because he's patient ID 1. He has appointment 1 and 2. Sally Jones has no appointment scheduled right now, and Bob Anderson has appointment 3. Okay, so inside the computer, this data is stored in 2 separate tables. Okay, whoever is collecting that information, they're not going to, or whoever, the administrative assistant or secretary or whoever, they're not going to have to look at these tables and line this stuff up. The computer does that for you. But this is how it's designed to be stored to avoid things like data redundancy and just general errors. Everything gets stored in one place, and it has a very specific organization that you design and implement, and then the people that use it, they only see the outer shell. whatever the developers allow them to access from the database, pull information out and put the information in. It's very locked down. So the design is purely so we can maximize efficiency. All right. We only have about 20 more minutes, but I'm going to keep going here. So one-to-many relationship. Here's the diagram, what the diagram looks like. So it uses two symbols, a 1 and an M, for one and many. It does matter which side the 1 is on and which side the M is on. Okay? And it takes a while to get used to this. So I'm gonna say it logically, and then hopefully it makes sense. So in this case, the way we have it here, appointments can only be scheduled by one patient. So each appointment can only have one patient. A patient can schedule many appointments. Okay? If I flip the 1 and the M around, what that means, and this always sounds ridiculous, an appointment can have as many patients as it wants, but a patient can only ever go to one appointment at the hospital. Okay, so that would be really weird, and that doesn't make any sense. So it's obviously the other way around. You know, lost my train of thought. Okay, anyway, hopefully that makes sense. It matters where you put the 1 and the M. You start on one side, appointments, have one patient. Patients schedule many appointments. It's really easy to get confused about which one you're looking at. So it's just one of those things. It's like knowing the difference between right and left. You just have to get used to it. Okay. Many-to-many relationship. Okay, so here is an example of a many-to-many relationship. So a many-to-many relationship always involves 3 tables. Okay, but it may only involve 2 entities. All right, so if we go back to the diagram, somewhere up there it has doctors and patients, and it shows this is how they did it. M and N for many to many. It doesn't matter where you put the M or the N. I just go left to right usually, or top to bottom, but it doesn't matter. So doctors can see many patients. All right, that's obviously many, because if a doctor could only ever see one patient, it doesn't make any sense. All right, a patient can see many doctors. Okay, if you don't like your doctor, you can switch. If you need to see a different type of doctor, you can switch. You can have all kinds of doctors. All right. If a patient could only ever see one doctor, that doesn't make any sense. All right. I try to think of examples, but it just doesn't make any sense. Okay. So in the patients table, we have 3 patients. In the doctors table, we have 3 doctors. All right. And so if we look down here, we only have two entities, okay, 1 relationship, but we have 3 tables. So what we actually have to do in a many-to-many relationship is you create kind of a go-between table that's made of, at a minimum, the primary keys of the 2 tables that are part of the relationship. So you can see that here. We started with the patients table, and we started with the doctors table, okay? The primary key of the patients table, what do you think it is? It can't be last name, because 2 people could have the same last name. It can't be first name, because 2 people could have the same first name. So in this case, it's patient ID. Hopefully no one has the same patient ID. That would be a problem in the computer probably, but anyway, different patient IDs. That's the primary key. So we just take that, and we use that as a field in our go-between table. Okay. And in doctor's table, again, last name, first name, those can be the same between people, so we can't use those. We can use doctor ID. We can put doctor ID field in there. So at a bare minimum, I need to pull patient ID and doctor ID because those are the primary keys from the two tables that are related. So this table here allows us to represent a many-to-many relationship, okay? And it makes sense because if we try to use a one-to-many relationship for a many-to-many, we won't be able to accurately represent all the possible outcomes. So, in this case, we can. Because we said a patient can have multiple doctors and a doctor can have multiple patients, we have to have this go-between table so that we can show that. So in this case, Bob Anderson, he is patient ID 3. Patient ID 3 does not appear. He does not have a doctor assigned to him right now. What about Sally Jones? She is patient ID 2. We have that represented here and here. So that means Sally Jones has the doctor 3 and 1. So that means she has Dr. Sarah Sweedler and Gray Ackerman. Okay. Jim Smith has the Dr. Sarah Sweedler. All right. And Sarah Sweedler has two patients. She has Jim and Sally. And we can see that. Okay, so I drew the lines on here just to make it easier to see where things are connected. But these are just three completely separate tables. All right. So let's say we wanted to assign assign a patient to a doctor. We would just create a new record here with the patient ID and the doctor ID, and then that would create that assignment. And so we don't have to. So we're just using the numbers here, so we don't have to store all of the name and all the information over and over again. Okay. We still have 15 minutes, but I think what I'm going to do is I'm going to stop the lecture here. I'll pick it up next time. You guys can definitely work ahead on this PowerPoint and work on the assignments, but I'm just going to take questions. So if you have any questions, let me check the chat here. Okay. Good job, everybody. How many people showed up here? 6, 7 people. Okay, that's pretty good. Anyone else who missed it, they can make it up by just watching it, because I'll be saving it. Okay. So if you guys get stuck on it, please don't wait to do these. Basically, every assignment, I think you only ever do the same thing maybe twice, but every assignment you're doing something different. So you can't wait, because unless you've done it before, you're probably going to have to ask for help. So don't hesitate to email me. And you guys can totally help each other. If you have questions, you can email me. You can post them in the discussion board. If you want to compare, if you get stuck on something, just let me know. Hopefully if there's a broken link or a file missing, you can let me know about that. So if you need more time on an assignment, if you need anything, just email me. Okay, sound like a broken record. So I'm just going to look at the notes here, and if you guys have any questions, just post them here. And then at 3:45, I will stop the stream, and I will be available by email. So hopefully that made sense. One downside to using this is that I can't see the bewildered look on your guys' face if I say something that I forgot to explain. So don't hesitate to ask questions in the chat, and then I'll periodically check it to make sure everyone's on board. So again, try your best. Don't worry if what you do is wrong in the beginning. When we go over it, I'll show you the right way to do it. So again, if you've had classes with me, it's a very sink or swim in the beginning situation, but it just feels like that. I totally can help you if you need it. Oh yeah, I'm going to mess around with the SQL on Replit here. Which one is it? Oh, I think it's this one. What if this as an example? Yeah, it does. Cool. So once we get far enough in design, the next step is taking your ER diagram and all the data you collected and organized into a plan, and you write it in as code. So it looks like on Replit, for the SQLite on Replit, they have an example here. And this is the stuff we'll be learning when we get into SQL. I'm not sure what this is. Some kind of properties, so ignore that. But here, we're creating a new table. These are the fields: name, height in meters, first descent. These are the data types. So name is the text field, height is an integer, so it's a number. When did you first ascend? When was the first ascent? And they got a date on there. And then down here, they're putting in all the data. So into mountain, assign. Here's the name of the mountain. Here's how many meters. Here's the date. And then they do that for all of these different mountains. And then down here, they're doing select average height of the mountains. Okay. So this is a, what is that called? This is the average function. Sorry, on the tip of my tongue. It's when you add a bunch of things together. Say it again. No, it's, here, come take a look at this. Is it, what is that called? It's just a weird terminology name. Not composite. It's in the slides. Let me just Google it here.
Oh, it's an SQL function you're talking about?
Yeah.
Yeah.
They're called something because they combine the records together. They're categorized by something.
Like a join? Is that what you're talking about?
No. It's right on the tip of my tongue. Okay, well, I'm going to look ahead in the PowerPoint because I know it. It just...
What's the goal of the function?
That one just takes in all the fields, all the values for one field and averages them together. So it puts the values into one thing, and that's what the word means. But I can't think of it.
I mean, it's an average function.
Oh, it's probably right on here. Aggregate functions, because they aggregate. Okay, not worth it. Oh, anyway, yeah. Okay.
So it's not a specific function, it's a type of function?
Yeah.
Uh,
It was a categorization of like count, sum, average. Sorry. Oh. Oh, okay. I have my screen share only on one browser window. Okay, thanks, Reed. Alright. Sorry, I didn't notice that till later. I have to minimize the chat because if I see it moving, I can't focus. Okay, anyway, if you go to, I'll put this in here again. Okay, if you go to Replit, log in, create a new thing, type SQL, do SQLite. I was just kind of giving you guys a preview of some SQL. So we hit examples, and then this one on the right, it has creating a table, inserting information into the table, and then down here on line 20, we're using an aggregate function to find the average of all the mountains. And so it's calculating that out here. And then here, I'm not even sure what they're doing here, but we can write our own query. So if I just do select star from mountains, then we can get a list of the mountains and all the data. So we'll be learning those commands eventually. But all right, 5 more minutes. If anyone has any questions. You can just stare at me. All right. Well, it doesn't seem like anyone's going to have any questions, but if you do, take a look at the material and you're confused by anything, just shoot me an email. We'll be doing this weekly. I don't take attendance, but it's much easier, obviously, to ask questions in person. So I will see you next week. Have a good week, guys.